So in today's lesson we have two parts. The first part is we're going to determine the equation of a line when the y-intercept is not a nice number. So this means it's not an integer. It would be something like a half a number or a fraction or some sort of decimal number. The second piece that we're going to do is we're going to do some conversions between standard and y-intercept form. Alright, let's start with the first example. So determine the equation of the line given the following graphs. So the first graph, what I want you to notice is we're going to look right to the y-intercept because this is why it's a special case. Notice that the y-intercept occurs between y equals 4 and 5. So this is some sort of decimal number that we have going on here. And if I was to put this into y equals mx plus b, remember our b is our y-intercept, I would be guessing at this point. So I need to find a way to not have to guess. And I'm going to show you the steps to that now. So the first thing that we're going to do is let's determine the slope. And remember, slope is m. And I've given you two nice points. So we're just going to do rise over run. So slope is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going 9 up. And we're going 1, 2, 3, 4 in the left direction, which is negative. Now remember, we can never, ever, ever leave a negative in the denominator. Okay, so we have a positive number divided by a negative number. The entire fraction is negative, so we're going to pull that negative up top. Okay, this is our slope. So we have one piece of the puzzle now. We know that the slope is equal to m. So I'm going to write that. I've got y equals negative 9 over 4x plus b. So this will be my second step. Now, I've also given you 2 points that are nice that lie on the graph. It does not matter which one you choose. The one that's more simple is the one that actually has the 0 in it. So I would highly recommend if you have a point that has a 0 in it, choose that one. It makes your life a little bit easier. But either one of them is fine. Now remember, a point is just an ordered pair. It has a value for x and a value for y. And it's unique for that line. So I'm going to actually just substitute my point into my equation that I have so far. So wherever I see a y, I'm going to put a 0. Wherever I see an x, I'm going to put a 2. So I end up with y equals negative 9 over 4. So I end up with 0, okay, now I've substituted the 0 for y, equals negative 9 over 4, and I'm multiplying it by the x value, which is 2, plus b. Now I like to use brackets. I would highly recommend brackets. Alright, now remember that any number can be written as a fraction. I can always make that over 1. And now I'm going to do some cross simplification. So notice that the 2 and the 4 are both divisible by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So if I simplify this, I have 0 equals, and negative 9 multiplied by 1 is negative 9. 2 multiplied by 1 is 2, plus b. Now what I want you to realize is that now we have one unknown, and I have a number here and I have a number here. Now I want to solve for b. So to solve for b, I'm going to have to add 9 over 2 to both sides. I can't add 9 over 2 and b together because they are not like terms. So I end up with 9 over 2 equals b. I now have my y-intercept. Well, that's great because I have my slope up here and I have my y-intercept down here, so I can now create the equation for the line. So I'm going to write out y equals mx plus b. Y equals, now I'm going to input my slope, negative 9 over 4x plus 9 over 2. Now I often get asked, why am I not putting in numbers for x and y? Well, a line has an infinite number of points on it. So we want to leave x and y open because I want to be able to find the other points. If I was to substitute a value for x, I would get a value for y out that occurs on that line. However, my slope is always the same for the line. The steepness for the line is for this specific line is always going to be negative 9 over 4. And for this specific line, my y-intercept is always going to be plus 9 over 2. There is only one y-intercept that occurs on my graph. Okay, so I was able to shrink mine, but you are not able to do that. If you'd like to grab an extra piece of paper, or you can always just write on this side as well. Alright, so I'm going to do the same steps. The first thing I'm going to do is determine slope. Okay, now slope is m, and I'm going to show you a second way. You guys have seen this before, but just as a reminder, it's good to keep reviewing. I'm going to write my 2 points from my graph. Oops, it's supposed to be a highlighter. There we go. I've just written them down. And I'm going to name this point point 1, and my point over here is going to be point 2, which means that this is my x value from my first point and my y value from my first point. This is my x value from my second point and my y value from my second point. Remember, these are just subscripts telling me which point they're coming from. And I'm going to use the equation that slope equals y2 minus y1 over x2 minus x1. Okay, so my y2 value is 2, and I'm going to take away my y1 value, which is negative 5. Now, this is really important to just make a little comment here. My y1 value is negative 5. This negative sign is coming from here. And the reason that's important is because a negative and a negative becomes a positive, which we'll get to in a second. Our x2 value is 3, and I'm going to take away my x1 value, which is negative 3. Again, really important, my negative here is coming from my negative 3, my x1 value. My negative here is coming from the minus in our equation. The reason this is so important is that I actually have 2 plus 5 over 3 plus 3, which in fact is going to be 7 over 6. Okay, so that was a lot of work. We could have just done rise over run, which is faster in this case, but I'm not always going to give you a graph, so that's why I did it the longer way. Alright, second, I'm going to write out y equals mx plus b, and I know what m is. M is 7 over 6. Y equals 7 over 6x plus b. I also have 2 points on my graph. Okay, I have negative 3 comma negative 5, and I have negative 3, 2. Sorry, positive 3, 2. It does not matter which one you choose. I know most of us like positive, so I'll choose 3 comma 2. Now remember, this is an ordered pair. It has an x value and a y value, and I'm going to use them to substitute into my equation. So wherever I see the y, I'm going to substitute a 2. Wherever I see my x, I'm going to substitute a 3. Oops. I was going to use a different color there, but it didn't work. Alright, so y is 2, and that's equal to 7 over 6, and x is 3. So I'm going to multiply. Actually, I like the brackets better, because then if there's a negative sign, you won't get confused. Remember, any number can be written as a fraction over 1, and I'm going to simplify. So 3 divided by 3 is 1, 6 divided by 3 is 2. So I'm just doing some cross simplification. So I end up with 2 is equal to 7 multiplied by 1 is 7 over 2 multiplied by 1 is 2 plus b. Okay, so my b is the only unknown that I have. I do have 2 constants, so 2 numbers that are not multiplied by variables, and I want to solve for b. So I'm going to subtract 7 over 2 from both sides. And I'm just going to write what I have over here. So what I actually have on the left-hand side is 2 minus 7 over 2 equals b. Now remember, when we are subtracting fractions, we have to have common denominators. So I'm going to start by writing 2 over 1, and then the common denominator will be 2, so I will multiply the top and the bottom of this one by 2. I'm just going to take this all the way up here. So I have 4 over 2 minus 7 over 2 is equal to b. 4 minus 7 is negative 3 over, and the common denominator is 2. And this is equal to b. Yay, I have b. I have slope, and I have b. So I can finish this and say, well, y equals mx plus b. Y equals m is 7 over 6 multiplied by x plus negative 3 over 2, but a plus minus is just a minus, so minus 3 over 2. Excellent, we have found the equation for that line. Alright, now the second part of this lesson is to actually go in between standard form and slope-intercept form. Now, I don't know if you remember, but standard form is, it looks like ax plus b, y equals c. And slope-intercept form is y equals mx plus b. Just as a note, these b's, not the same. A small b and a big B, definitely not the same, but they do not have anything in common here, okay? So just be careful. Maybe it was poor choice for coefficients, but it is what it is. So our example asks us to convert 2x plus 3y equals 6 into slope-intercept form. So what you need to notice is that slope-intercept form solves for y. I want to know what y equals, and there's going to be variables involved. I'm going to start by writing our actual equation that we have down. Oops, equals 6. My goal is to get y by itself. Now, our y is here, and at the moment, this is making it so that it's not by itself on that side. I want to move the 2x to the other side. So in this case, I have to subtract 2x, and I'm going to subtract 2x from both sides. So I end up with 3y equals, and I'm just going to reorder it because what I want you to notice is that it's mx, the x is in the front there, so I'm also going to put the term that has the variable x in the front as well. So I get negative 2x and plus 6. Okay, now we're pretty close to y equals mx plus b. Notice though that in mx plus b, it's like the coefficient, there's an invisible 1 there. But right now our coefficient is 3, so I want to get rid of that 3. The only way to get rid of that 3 is to divide, and I'm dividing every term in our equation by 3. So here I can simplify. 3 divided by 3 is 1, so I get y equals, now it's negative 2 over 3x, and plus 6 divided by 3 is 2. I now have y equals negative 2 over 3x plus 2. This is in slope-intercept form, which is what it asked us to do. Alright, but the next example we're going to go the other way. So convert y equals negative 2 over 3x plus 7 to standard form. So again, I'm going to start by writing y equals negative 2 over 3x plus 7. Now, standard form, just first remember it's ax plus by equals c. So notice that the variables x and y are both on the same side. That's a really good thing to start with. If I know that they all have to be on the same side, let's move it so that they're all on the same side. So right now I've got y over here, and I've got negative 2/3 x over here. So I need to move this to the other side. So I'm going to add 2 over 3x to this side. Negative 2/3 x plus 2/3 x is going to be 0. So on our right hand side that's going to go away. And I'm going to add 2/3 x to the other side. So now I have y plus 2 over 3x equals 7. Now we're pretty close, but one of the things with our coefficients and constant is they need to be integers. So no decimals and no fractions. So think about this. I have to get rid of this 3. If I want to get rid of this 3, what would I have to multiply 2/3 x by so that it becomes 2x? I hope you're telling me 3 right now. If I multiply everything by 3, so if I multiply this by 3, I have to multiply, if I multiply one thing by 3, I have to multiply everything by 3. I'm just going to rewrite it so it looks a little bit nicer. I have 3y plus 3 multiplied by 2 over 3x equals 3 times 7. Now, nothing's going to happen to the 3y, but it's the term with the x that things cancel out. I don't want you to write 6x over 3. What I want you to notice is that you can cross simplify here. 3 divided by 3 is 1. So I end up with 3y plus 1 multiplied by 2x is 2x, divided by 1 multiplied by 1 is 1. I don't need to write this piece. Anything divided by 1 is itself. And that equals 21. And the last thing that we have to do is in standard form, the x value always comes first. So we just have to switch them around. 2x plus 3y equals 21. So all I've done here is I've moved that one and that one around. Their signs came with them. I now have it in standard form, so I am done.